This is video 47, and I'm going to try to show you how to use one of the more commonly used standard template library templates. Let me go to Finder and go to Us and go to Program 5 STL example, and I've already got a head start on it. Open with not Xcode, that's way too much. Sublime Text, there we go. Okay, and look at what a head start I got. I've already got the header documentation. This is called example STL. And it's going to be about dogs, of course. Since we have so little time left, we've got to squeeze in as many dogs as we can. I hope there's nothing terribly strange looking here. Let me see. Scroll down. IOStream, include IOStream, using namespace std. I set a sentinel value because I'm going to be reading a list of input. And here's a dog data type. No, the reason I did this in advance is because there's nothing new here. I hope there's not. String name, and there may be unsigned is still unfamiliar to you. That just means it's a positive integer, strictly positive. It can't be less than 0. So a dog can have a name, an age, and a color. I even got some utility functions already set up to print a dog if one's already filled in, and to read a dog if it's not already filled in. Tiny little main program. All it tries to do is read dog into a temp dog variable and print dog after it's been read in, and then it returns 0. Print dog prints out the name and the color and the age. Read dog passed in by reference, and since there is a sentinel, if our user types in a sentinel value, it returns false. It did not successfully read a dog structure. Otherwise, it stays here and reads in all this stuff. So you can see all that stuff on the screen, and I think I've already got a console window open to the right place. Do I? And let me make sure I've got the most recent version saved. File save, Command S. It would have to be, wouldn't it? Because I just now opened it from disk. Make sure I'm in the right directory. There it is, example stl.cpp. So G++ EXAMPLE. Should have made a shorter file name. Too late now. .cpp. And there we go. Whoops. The current directory a.out. Name waffle. Age 4. Color red. So what it did, all it did was read in what I typed in with the read dog function, and then I turned around and printed it out using the print dog function. That's not what this example is about. No. This example is about trying to use the standard template library. Okay, so let's see. Use the STL, and pause for a second. Let me surf over here, Finder. Program 5 PDF. This is your Program 5 assignment that I emailed you. Here it is. This is the tutorial and a reference for the standard template library. You can click on the link that's actually in the programming assignment. That's what I just now did. It takes you to this tutorial, standard C++ standard template library, and all this kind of stuff. Now the programs are pretty short and sweet, but some of them do. How can I get rid of that? Hide add. I don't want that either. Some of them do assume a little bit of knowledge. Let me see. The one I'm going to use is a vector, Y vector. Well, it's almost like a hybrid, the way I've described it, between an array and a linked list. It's unbounded. You can put more stuff in it. It acts like it's unbounded from the programmer point of view. And then you can access it like you do an array with index numbers if you want to. And you'll see lots of stuff here you recognize, some maybe you don't. Queue, if you have an application for a queue in Program 5, you could use that. Stack, I've already suggested you might use the stack. This other stuff, I don't even know what most of this stuff does. They do assume some knowledge about iterators. Don't let that word mess with you. An iterator, you could view that as a publicly visible cursor. So here's an example right here. They even call it PTR. I don't actually recommend that. That's not a good idea necessarily. But a vector of integers, iterator, pointer. First of all, what on earth is a vector of integers? Well, vector is a class template, meaning that it's a cookie cutter to make a class where you fill in the data type. So in this case, whoever wrote this tiny little example program filled in integer so that they will have, in effect, an array or a list of integers to work with. You can actually put any previously defined data type inside the pointy brackets, and that serves as our little data type.h file. Do you remember those? Where we specified what value type and all that stuff was? Well, that's it right here. What's in pointy brackets is you are filling in the blank of I want a vector of these kinds of things. I want a vector of integers. And I hope it will make more sense when we actually look at this stuff. You know what? For now, at least, I'm going to get out of here. Let me get back to the original page. Well, no, you know what? Let me click on vector first because that's the one I want to look at. Sorry about all the scrolling around. Vector, and here are some iterator methods on here. You can go to the beginning. That's like our go to front on a linked list. Go to end. All these kinds of things. And then here's an example of how you can actually go through it. Push back, that's a pretty important function. That's the equivalent of, in our linked list, you'll notice I'm flipping back and forth between descriptions as if it's an array and descriptions as if it's a linked list because it kind of acts like both. Push back would be if we were to say move to back on our linked list and then insert. It does both of those things. It puts it at the end. Or if we had a queue, it would be like putting something in the queue. It goes to the very end and puts it in, and that's why it behaves like it is unbounded, unlike an array. Even though we can access it like an array with square brackets if we want to, it is in effect unbounded because we can put new things at the end if we want. Now what was I going to do? Oh yeah, I was going to go to the intro page, and since this will be used, I'll probably use it several times here. I'm going to copy that and quit Safari, buy Safari, and even buy PDF for now, and buy Finder for now, and use the STL. Before I forget, I'm going to put the reference, the link to the reference I'm using right here. Command V, that's it on Mac. There it is. There's the standard template library. Now at my fingertips. Use the STL vector, for example. And it could just as easily have been queue or stack or whatever. But like I said, vector is one that's very commonly used. So here's what we got. I got a dog structure, which is now a data type that I could use if I want to. You know what? I could make a vector of dogs right away. If I could remember that scrolling on the Mac is upside down for some reason. It scrolls the wrong direction when I roll the little mouse indicator. I'm old and technologically challenged. We ask that you bear with us. Temp dog was just so I could read one and print it out. A vector, V-E-C-T-O-R, and I could put, oh, wait, it was trying to help me. Even Sublime is trying to help me. Vector, oh, yeah, big deal. Stand STD vector is where it's located. Pointy bracket, dog, where they had integer, I'm going to put dog. And since it's like an array of dogs, I'm just going to call it dogs. It is, of course, case sensitive, and to make sure that I've invoked it properly, I'm going to file save and see if this will compile. All I did was add one line so far. This is going to take forever, I know, if I do just one line at a time. Up arrow takes me to G++ vector dog. Oh, yes, of course. Undefined template. Well, each one of these standard template library templates, some of them are collected, but I think most of them have their very own little include file. #include vector, V-E-C-T-O-R. There we go. Now, Command S to save on a Mac, and back over here, up arrow, try it again. There, I meant to do that. Okay, sure. Now I've got a vector of dogs. What am I going to do with it? Well, I'm going to read a bunch of dogs, and as I read them, I think I shall put them in as if I'm using a linked list. So I'm going to even say that. Make, whatever it is, read a bunch of dogs. I'm also demonstrating terrible typing, if you need a lesson in terrible typing. Linked list style, I'll call it. You know what? I'll just call it list style. I'm going to have to quit referring back to lists and arrays all the time because vector has its own set of rules. Okay, I've got a read dog function, and I believe, even though I ignored it here, it is returning success or failure. Yes. So I can do a while loop that's doing nothing but testing the return value of that. While read dog into the only variable I got is temp dog. So that's just saying as long as I keep reading and the sentinel hasn't been typed yet, then what am I going to do? I'm going to do the dogs. all of a sudden I'm using this vector, and if you recall, I said we're going to use pushback, which is the equivalent, if you read the documentation carefully, that's the equivalent of move to the end of the list and put it at the back of the list. So there we go, temp dog. And Mama didn't raise no standard template library expert, so I'm sorry, you're just gonna have to indulge me. I'm gonna try to compile it every step. And it's clean so far. So I did use pushback correctly. Print them out. Print out the dogs. And which one is more comfortable? You know what? I think array style is probably more comfortable. Array style. I cannot help myself. I'm going to go back and forth between referring to it as an array and return to it as a vector. Here's array style. For int I equals 0, I is less than what? Since this is like a list, how's it going to know how many things are in there? Well, if you look at the methods, one of the things we can do with a vector dog object, now that it's an official object type, is get the size. That's just an accessor. There we go. You know what accessors are, plus plus I. And I'll even label it with the index number. Cout dog, square bracket, I, close square bracket. Wait, quote first, quote. But I'll type and not talk. There. No! Awful, colon space. I'm trying to make the output look pretty, and I'm paying the price for it. You know what? I'm also going to tab over just so this stands out a little better. /t. Dog sub I, and how about we print the dog? Print dog. Oh no, which one are we going to print? Dogs. And here's what I meant by array style. I almost said doggy style. I meant array style. I did say it anyway. Huh. Okay. There. Let's see. I better label it. Here come the dogs. Chance of that working the first time, a number approaching 0, but you know what? I should probably save it first. Did I save it? Command S. Stop it. I don't want to buy you now. Cancel. Oh, it's Control S, isn't it? File, save is, no, it's Command S. I guess this window just pops up now and then, doesn't it? And the G++ command. No! No. Let's trial and error through this together, shall we? What's the first error? Well, it did do waffle. Implicit instantiation of undefined template vector dog dogs. Well, I've got the include file, vector, vector dog dogs. What line does it not like? Oh, it's something about when I'm printing it out. Oh, that's a CS2 level error. Look at what I'm trying to do there. Print dog is a Boolean function. I'm trying to print out, no, it's even void, even worse. I'm trying to print out a return value of void. Silly me. So what I want to do is print the label and then separately call print dog. Silly, stupid me. That was not even a template error. That was just a general intelligence error. Save it and up arrow it, and well, it compiled cleanly. Let's see if it'll run. A.out. Name, waffle, for red. Okay, it's at least gotten to where it's trying to read the, it should have printed something, shouldn't have. Let's read the list of dogs or something like that. Okay, Michael, around 11, black. And Michael Solomon. That was me entering delete by the wrong key. Solomon around 12, I believe, and brown. I don't know why I keep going. Let me type the Sentinel X. Oh, mental note, I need to tell them how to stop. But look at this. Here come the dogs. There are only 2 dogs. Dog 0 is Michael, a black 11-year-old. Dog 1 is Solomon, a brown 12-year-old. And look at this. It does look like an array, doesn't it? Even though those were pushed back one at a time. That's my new verb, push back. They were pushed back one at a time into the end of something like a list, and then I turned around and printed it like an array. And it's doing everything I'm telling it to, except I need to see out. This is just professional polish here. Enter the list of dogs, digs, or dogs. Stop it. And whatever I call the Sentinel. Sentinel. What a creative name. Sentinel. To quit. Endle. Now, what were my other mental notes? I had more than one, didn't I? I pushed them back to a non-allocated vector, I guess. Look what I did there. I didn't remember to keep a list of my mental notes. Well, let me look at the output and see. Here come the dogs. That's a big space there between those. Oh, it's tabbing over when it prints dogs. Let me get rid of the tab. That'll clean that up a little bit. Not that it matters so much. Well, style and grace matters. Command S. Try again. Run again. Jojo. Jojo's 2 and white. I don't think I need that separate dog anymore. We're jumping to the list. The list, Rover, age 120. Rover's been around forever. Color black. Name, Tom. Tom is 3 and red. And Darby is 17 and blonde. And now I'm done. Did it say X to quit? Yes, it did. I just ignored it. X. Here come the dogs, and that output looks a lot better without the tab. Rover is black, 120 years old, yada, yada, yada. So all that's working okay. What's my new mental note? Put an inline at the end just so it looks prettier. So before return 0, see out Endle. Print out dogs. There's no reason for a period there. Print out the dog's array style. Let's put another dog in there to show you that the size is expandable. Put just one more dog in the vector. I'll stop calling it a list. Stop calling it array. And I'll just, what I'll do, I'll just call read dog. And it does return Boolean, but I'll just assume they're not going to type the Sentinel. Read dog, and there's no reason not to reuse temp dog again. Temp dog is just a holding area until I decide that it's not the Sentinel or whatever, and then I'm ready to put it into the vector. So if I'm successfully reading something in the temp dog, the little lobby variable here, then I put that, it actually makes a copy of it. It's not copying by reference, so I don't have to worry about preserving the value of temp dog. It makes a copy of the value of temp dog, that structure, into my vector of dogs. And now they're all separate from each other. Read it, and I don't want to print it back out. I just want to push it back. Dogs.pushback. Just to add a little interest before I do something else here. Pushback temp dog. So there. Now I've got all the dogs that were there before. Now I'm going to print them out. Print out the dogs. List style. Style. Now, to print it out list style, well, let me label it first before I forget. Here are the dogs again, Endle. Here they are. Here they come again. There. Style points. And what do? We want to set up vector, which is now a data type. Vector dog, it's kind of like my own homemade data type. It's a vector of dogs. And the class name is altogether vector dog. Vector dog is the name of a class now, believe it or not, that I can use in my program. And one of the data types defined inside class vector dog and class vector or anything else is what's called an iterator. Iterator. An iterator, I think I mentioned it when we were looking at the website, but I'm not sure. An iterator, from our perspective, is a cursor. It's like a publicly visible cursor. And they called it pointer, so I'm going to call it pointer. Well, that sounds like a dog, doesn't it? Okay. How about dog pointer? Just to emphasize the difference between index number I and pointer variable dog pointer, which I can now use as if it's a pointer variable and access the dogs that way if I want to. The for loop is going to look a lot different though. And I'll use my iterator I just now set up. I could have defined it inside the for loop, but I wanted to say something about it separately, and I just did. For dog pointer equals, and you can look up these methods, these member functions. Dogs is my vector of dogs, and I want it to start at the beginning. So begin is an accessor member function. That, in effect, is going back to the beginning of like what we had as a linked list. That's like move to front. So what I did was take this externally visible cursor called an iterator and dog pointer. I set that equal to the first thing in the list, the beginning of the list, and I want to what? I want to keep going as long as dog pointer has not reached the end of the list. So while dog pointer not equal to, well, where's the end of the list? It's at dogs, and all this is in the online documentation. I'm going to stop saying that. Dogs dot what? Dogs dot end. I think that's it. Did it recognize that? END? It doesn't look like it recognizes that. I don't know. I'm a little wary, getting a little nervous here. And here's another strange thing. Plus plus dog pointer. Look how it's like a Frankenstein version between an index number and a pointer. The plus plus dog pointer doesn't add 1 to it. It makes it point to the next dog in the vector. That's a mouthful right here, isn't it? Dog pointer is an iterator. We can think of it, it's best for us to think of it as a cursor, which we're intimately familiar with at this point. See what I did there? So I set that to point at the beginning of the dog vector. As long as it is not at the end of the vector, then I increment it with an overloaded plus plus operator. That's what it is. It's overloaded plus plus operator to make dog pointer point to the next thing in the dog vector. Then how do I print it out? I hope I can print it out like this. Print dog, and I'm not even going to give it an index number because we're not paying any attention to index numbers here. You use the indirection operator, which is also overloaded. What's pointed at by a dog pointer? Yikes. Holy moly. Am I even going to try to compile that? I might as well. Command S. Up arrow, up arrow. Please, oh please, oh please. The very first time. A dot out. Name. Oh, I forgot to get rid of that one. Age 4. Color red. Enter list of dogs X to quit. Okay, Michael. Age, who knows, 11. Color black. I'll put some more in there. Michael, Solomon. With the wrong capital case. Age around 12. He's brown. Michael Solomon, Leo, about 10. He's black and brown, but I'm just going to put black. Michael Solomon, Leo Trout. He's 7, maybe. He's tan. We'll stop there. Now, this we already had figured out. This is nothing new. Here come the dogs, and this is array style. Up here, print out the dogs array style. Our good old, comfortable, even though I messed up with the gunk in the cout statement and everything, really all you got to do is pass in the next array element looping through where dogs.size tells you how many things are currently in that vector. It's like you're keeping a separate counter variable to tell you how many things are in the array. You don't have to do that with a vector. You can ask it how many things are currently in the array. And I'm calling it an array on purpose. This little chunk up here of code views my vector of dogs as an array. And that's how it printed it out, index numbers and all. Here comes a moment of truth. After it prints out those, it started going again. Oh, this is just one more dog in the vector. So we're not ready for the pointer stuff yet. Okay, the name, put Darby. Age 17, bless her heart, and she's blonde. Now let me see where we are in the code right here. Right here, I'm reading in, this is just put one more dog in. So just now I'm reading in Darby. It should put Darby at the end, after Trout, at the end of the vector, just like it's inserting at the end of a list. Here they come again, and all of this stuff with the weird notation here, all of this is because I decided, you know what, I changed my mind. I want to view my vector as a linked list. To do that, I got to get access to individual elements through a pointer. You can't see me, but I'm doing air quotes around pointer because it's not technically a pointer. It's a special thing. It's a special data type defined for use with vectors and other container STL templates called an iterator, but we know it and love it as a cursor. So I set up a cursor called dog pointer and made it point to the first one. As long as it's not past the end, then I increment dog pointer, which makes it point to the next one, and I dereference it. This is saying print dog. What's pointed at by dog pointer? Look at this, and look at that. Look at this, look at that, look at this, look at that. This is printing it out using array notation. This is printing it out using pointer notation. Will it work? Press enter, and look, it did. It didn't tab over because I took out the tab. But it says Michael is a black 11-year-old, Solomon is a brown 12-year-old, yada, yada, yada. And look, it inserted Darby at the end of the array. So it is a dynamically sizable array from one point of view, and it's a good old-fashioned linked list from another point of view. And it would be worth your time, I would say, at least to look at the queue template, look at the stack, especially template. That's going to be really handy for the crumb trail if you want to print out the crumb trails using standard template library. You can find more than one use for vector. Actually, any place where you would use a linked list or use an array in Program 5, you can instead use a vector. So knock yourself out. There are all kind of stuff here. And as far as demos go, I'll answer questions, but I think I better quit while I'm ahead, if I am ahead. And I'll see you online.